Hello, today we're looking at measuring of relative standing and density curves. Here, if we have a data set where the mean is 42 and the standard deviation is 5 units, find the value that is 1 standard deviation above the mean. So we have a mean at 42. Standard deviation is 5 units away. And so that would be at 47. So 47 is the answer. Now, if same situation, let's do 2 standard deviations away. Oh, that's 5, and that's 5. And so I'll go up to 47. I'll go up another one. Now I'm at 52. So my answer is 52. Now, how many standard deviations would 50 be above the mean? Now, that's a little tricky. We have 42. We have 1. 50 somewhere in between. Well, we know this distance is 8. So if I take 8 divided by 5, that's about 1.6. So this is 1.8 standard deviations above the mean. Now, that's a really important number in statistics. And we want to put things in standardized units. And when we say the word standardizing, we're converting values to those standard deviation units. We're going to strip them of their context. And now how many units are they from their mean? Now, our way that we do that is we find this thing we call it a z-score, or a standardized value. They'll use these words interchangeably, z-score and standardized value. And to do that, we take each x-score, and we subtract the mean, and we divide it by the standard deviation. That gives us our z-score. For instance, if I want to find the z-score of 86 in this data set, so I look at the data set. If I just had this, I would type it in and try to figure out these values. But since I'm prepared, I'm going to take our data point, 86, and I'm going to subtract out the mean, and I'm going to divide it by my standard deviation. So when I do this, I get 6 divided by 6.07, which produces a value of 0.988. So pretty close to 1. So that's about 1 standard deviation above the mean. Now, what's great about standardized values is they allow us to compare things that have that aren't as easy to relate. So if student A scored 7 on a math quiz and student B scored 12 on the same math quiz, those are easy to see that this is bigger. But if they are on different math quizzes, z-scores are a good way to compare who actually did better. Now, if student A earned 75% on a history test, but student B earned 62% on a science test, z-scores will help us see which one of those is actually better relative to their peers. Also, like an athlete running a 400-yard dash, we could compare that to another athlete running a 100-yard race. We can see using z-scores things that we can't see with the actual numbers. For instance, on a history test with a mean of 40 and a standard deviation of 4, Ed scored 44. On an English test with a mean of 30 and a standard deviation of 6, Alice scored 35. Who did better relative to the other students taking that exam? So let's take Ed for example. We want to find the z-score for Ed, which we take 44, his x value, minus his mean, and divide it by a standard deviation. So Ed scored 1 standard deviation above the mean for his class. Let's look at Alice. Alice scored 35, and the mean was 30, and we divide by 6. So that's going to be 5 divided by 6, which is 0.83. So she scored 0.83 standard deviations above the mean. Now, even though these are different tests, we can say Ed did better relative to his peers. because his z-score is higher. All right. Now try these on your own.